Hello, everyone, and welcome to the Ethereum and Scroll section as part of the Rising program. My name is Amel Castro, and I'm the at Scroll. And today we're going to discuss about what is Scroll, what is Scroll role on the blockchain and scalability, and also how Scroll works, how everything works behind the scenes. So let's start by what is Scroll. For users and developers, Scroll is pretty much Ethereum. Same experience. If you're used to Ethereum, you should be familiarized with Scroll. If you're a developer, a Web3 developer, and have used Hardhat before, you may be familiarized with this. This is a Hardhat config file, and the only change that you need to do to deploy Scroll is just change the RPC. If you are working with either Solidity or Viper or Yule, everything works on Scroll. If you are working with Foundry or Remix, it should work exactly the same. So you don't need to download some extra SDKs or library. Everything should be seamless. And in terms of ecosystem, Scroll has hosted so far a lot of apps that are also available on Ethereum, such as Aave, Uniswap, Safe, Compound, and many more. And also, there are many Scroll native applications that were born on Scroll, and also some dev tools that you may be familiarized with, such as Chainlink, the Graph, and other. And if they are not already on Scroll, you should tell the developers to come to Scroll, or there should be already an equivalent, because everything is very, very similar. Also, Scroll is a very young project. It was born on October 2023, and so far it's been growing, and we're very happy about it, and we expect it to continue to grow even more. So now about blockchain and scalability. This is the reason for Scroll to exist. So I want to share with you guys this sentence that I found on Ethereum.org website on the landing page, which says Ethereum is open for everyone, wherever you're in the world. All you need is the internet. This is the Ethereum mission. This is the Ethereum vision. But of course, there is a big problem. The transaction fees are so high and Ethereum is very slow. And the problem is that we're leaving behind everyone that is not able to afford these super high fees on Ethereum. And also, we're leaving behind many use cases and that are not able to come into play, this lack of scalability that we have experienced so far on Ethereum Layer 1. But how did we end up in this place? Like just before going into the solution, how did we end up here? We need to understand a few concepts here. The first one is that Ethereum is able to make work. It's able to compute code. And this computation is measured in gas that is paid to validators, that they are in charge of securing Ethereum. All this work has to fit in blocks. These blocks, the block size is limited. And when a blocks get filled, you have to pay extra fees so your transaction get included faster. This is what we call block scales. And when a blocks get filled, everything gets more expensive. And this is why Ethereum is so expensive, because everyone wants to use it at the same time. So the gas fees go very high. You may have heard about this, which is the trilemma. And the trilemma explains the challenge of making a good blockchain. For a blockchain to be considered good, it has to be scalable, fast and cheap. It has to be decentralized, which means that anyone should be able to send transactions wherever they want. The nodes should be easy to run for everyone, and secure. All blockchains are susceptible to the 51% attack. Like in Ethereum, it's some sort of 33 or 66%, something like that. But the more validators Ethereum have, going to become the more secure. So today, Ethereum is the most secure smart contract blockchain in existence. So we could say Ethereum, and both Ethereum and Bitcoin, in our opinion, rightfully so, have focused on decentralization and security. This has been the biggest focus. It's very easy for Ethereum. It's very easy to run a node. You can run it on your machine, and it's very secure because it's proof of stake network that has the most of stake. So the more stake it has, Ethereum could be attacked, could receive an attack, an economic attack, by running a lot of malicious validator, but that will be way, way, way too expensive because Ethereum has a lot of validators. Ethereum has focused on decentralization and security, but has sacrificed scalability. The thing is that if we focus too much on scalability, the problem is that we go back to Web 2. We go back to Amazon Web Service. We go back to Google Cloud. The new aspect of blockchain resides in decentralization and security, but this doesn't mean that Ethereum just forgot about scalability and is going to remain expecting forever. But the thing that Ethereum did is just focus first on securing the decentralization and security, and then looking for a way on how to become scalable. How can Ethereum achieve this? So there were many ideas. on how to make all this computation secure, fast, more and less expensive. So the first idea is the one you can see on the left, is sharding. So sharding is the concept of if Ethereum becomes like a super high liquidity network and you have a lot of validators like today, you can like grab some pieces of the network, just slide into pieces and some validators. So instead of all validators validating all the network, you can have some group of validators validating some parts of the network. Of course, the problem with this is that you will have to sacrifice each shard, each like silo, each computation should be like less secure because you will divide the number of validators on each shard. You will need a lot of liquidity, and even if you have a lot of liquidity, this is not like the most secure approach. So that's why Ethereum first was focusing on making sharding roadmap, but now they focus on a rollup roadmap. So rollup roadmap is that many chains like are executed off-chain. We call this off-chain computation that in the end gets secured on Ethereum. So there is no fragmentation of validators because all the validators will stay validating Ethereum. Why rollups? First, as I mentioned before, security. You don't need to divide the validator set. All the validators will be validating all the rollups, which Scroll is one of them. The second thing is that all the rollups can experiment with different technologies. If one technology is better than the other, or if one technology fails, it's going to be just in a small area of Ethereum. It's not the whole system is not going to be compromised. So the system is more resilient. And also something very important is that Ethereum works on the subject of subtraction. So the idea is to decentralize Ethereum, have to be hands off, and the community and the system will carry on by itself. Roadmap from Ethereum, all the rollups, all the layer twos like Scroll will create their own technology, but also their own culture that it's connected to Ethereum. So you can have like many aspects of Ethereum through different lenses. This leads us to a lot of like not only technical but also a cultural experiment, which I think is very, very interesting too. But the big problem is, okay, we're going to do off-chain computation. It's going to be stored on Ethereum, okay, but how do we make sure that this off-chain computation in the rollup don't cheat? How do we make sure that the rollup doesn't cheat us? Of course, the idea of everything is that on Scroll, you don't have to trust Scroll. You have to only trust Ethereum. But how do we make this happen? So, okay, layer 2s are protocols on top of Ethereum, but Ethereum is in charge of security. All the security and consensus happen on Ethereum, but all the execution and the processing of transactions happen on layer 2. And we're going to talk about more about this in the what is the current state of things, what is the future of executing this transaction on layer 2s. And Scroll specifically is the general division of work. So layer 2 makes the execution and Ethereum makes the security. Okay, so in terms of computation, we have a couple of two types of rollups. You may have heard of the optimistic rollups and the CK rollups. So the first one that we had are the optimistic rollups, which are based on this optimistic technology that basically means that everything it's okay unless something is not okay. And so that's why we have a lot of time from reaching back in and port from optimistic rollup, because we have a very, very, very like long finality time. Finality time is when a transaction gets accepted on Ethereum. A transaction can be sent on layer 2 very quickly, but then it will have to generate a fraud proof. It takes usually about a week to make sure that everything is correct. And because the optimistic rollup just assumes that everything is okay by default, unless someone in that week period from finality time proves otherwise. But that's why a new technology was built, which is the CK technology. So CK technology, you can use it for different purposes, but in this case, we are using the CK EVM validity proof to generate a CK rollup on Scroll. What does this mean? It means that all the transaction that is happened off-chain generates a proof that was executed correctly using this CK technology, and then it gets stored on layer 1. You may have heard about CK because it says zero knowledge. You may think that Scroll is a privacy network, but it's not. All the transactions, as I mentioned before, are very similar to Ethereum. On Ethereum are public, so on Scroll they are also public. This means that the validity proof on when you send a transaction on Scroll, a mathematical proof that your transaction is correct is generated. and that is sent to Ethereum, and Ethereum will accept the transaction in a smart contract. So why is this technology better? Because the finality time is in minutes and not a week. It's not days, it's just minutes. And you are not assuming in any point of time that your transaction is good. You are proving that your transaction is good. So you as a user, you as a developer, you don't need to understand anything about zero knowledge or about privacy to use Scroll. But of course, you can build in a later section. We're going to show how to build privacy apps, but you as a developer don't need to know anything about privacy specifically. And something important about Scroll was how Scroll was born, and like what is the origin of the project. So Scroll is built on top of what we call the CK-EVM project. That is a GitHub project that was started by the PSC, which is the Privacy and Scale Inspiration. It's a branch from Ethereum Foundation that is experimenting different things, like the most futuristic things. And the PSC built the CK-EVM because they were trying to build a CK layer 1, turn Ethereum into a like zero knowledge blockchain. And of course, it's a lot of work involved. But what Scroll did, Scroll like founders really like this project. There is a lot of things that we need to do to turn Ethereum layer 1 into a CK layer 1, a lot of more research to do, a lot more of coding. So what Scroll did is, we're going to turn this into a rollup. So Scroll turned the CK-EVM into a rollup. So that's like one step ahead, like just moving one step forward to prove that Ethereum in the future can become a CK layer 1 and have all these like scalability and even privacy features. But for now, Scroll is just proving that a rollup can be built. And today, Scroll is proudly the biggest contributor. Now it contributes more code to the CK-EVM, even more than the PSE, but they work together. And also, it's an open source project. If you are interested in this, of course, it will be super nice for you to contribute, as an open source contributor, because this is all open source and worked in together with the PSC. Now about how Scroll works. So let's dive into the architecture and let's dive in about how everything works behind the scenes. As I mentioned before, let's say that Scroll is a layer 2 on top of Ethereum, the layer 1. But all the transactions that you do get confirmed super fast, like in seconds, like 1 or 2 seconds. If you make a swap on Uniswap, 1 or 2 seconds. If you go to your off-ramp and off-ramp some ETH, also a couple of seconds. If you land on Aave, if you mint an NFT, everything is super, super fast, faster than Ethereum. But this is like the first phase of your transaction when it get pre-committed. On MetaMask, you will be able to see the change. On Rabby or whatever wallet you're using, you'll be able to see everything super fast. But this is just the pre-commit. The second phase is the commit. So Scroll patches a lot of transactions, they group them, they put it into a rollup. That's why it's called a rollup. They group it and they store it on Ethereum layer 1. And why do you want to store it on Ethereum layer 1? This is for security. Ethereum is the most secure smart contract blockchain. So Scroll grabs all the data on Ethereum. So if you want to get out your funds on Scroll, in the future, you will be able to force Scroll to make any transaction because all the data is on Ethereum. That's why it's important to have all the data always on Ethereum, and Scroll specifically is using the dark sharding as any other rollup to make the transaction cheaper. We're using the EAP for 844. So all the transactions are cheaper that way because Ethereum now it's pushing, so layer 2s are cheaper, easier to build. Okay, but after your transaction data is on Ethereum, there is another step, is the finality. From all the blocks that you store the data on Ethereum, now you will submit a zero knowledge proof that all these blocks are valid. And this is a smart contract on Ethereum that is waiting for all this, like a big proof that all the transaction that happened on Scroll is valid. And if there is something, if someone tries to impersonate you or impersonify you, or someone is trying to put a malicious transaction, it won't happen because Ethereum itself, it won't accept the transaction. So once a transaction is finalized with each a couple of minutes on Ethereum, it should be reflected. On Ethereum, it's like super, super safe. So at that point in time, you don't have to trust Scroll anymore. You only have to trust Ethereum. This is, like, as you can see, is divided in 3 layers. The first layer is the settlement layer, which is purple part is Ethereum itself. Ethereum serves as data availability layer and also for proof verification, but also it has a bridge, so you can bridge back and forth either ETH, ERC20 tokens, NFTs, or send any transaction that you want from one chain to the other, from Scroll to Ethereum, back and forth. Then is the sequencing layer. This is the same as you may be familiarized with. This is where all the transactions are handled. This is your RPC nodes. This is everything you are used to. Validator here, we only have execution because all the validation is made, of course, on Ethereum. And then the orange or yellow part is the proving part. This is the zero knowledge part. So all the transactions are sent to the coordinator, and the coordinator, with the help of the provers, with a decentralized network of provers, is able to make a proof for every single transaction execution. It bundle the proof and then send it back to the rollup contract for security. If we want to dig a little bit deeper, we have the Ethereum Layer 1 on the top. And as you can see, execution on Layer 2 contract happens by combining all the Layer 1 transactions, all the transactions that are coming from the bridge, with all the transactions that are happening on Layer 2. Because, of course, you can send a transaction from Ethereum to Scroll. It can be either sending ETH, tokens, or any arbitrary transaction as you want. So all the transactions get combined into the executor. And the executor works exactly the same. We are running a get node, but in the future, we are looking into running a red node, which I think is going to be super interesting. A lot of new use case for combining, which because it combines better with CK. It's just like any other execution node, Ethereum execution node that you may have. With the difference that all the trace, all the executions, all the transactions are sent to the coordinator. And the coordinator distributes the work in a decentralized network of provers, which are right now part of Scroll, or also people outside of Scroll they are helping to create this proof fast and then send it back to the coordinator, so the coordinator can finalize the transaction on the rollup. Couple of things to mention here is that Scroll, as any other rollup in existence today, important to understand what are the next steps. So the next steps are, how do we incentivize the proof? That's one thing that we have to do. How do we make sure there are quality provers that generate the transaction proof faster? And also, do we want to make this permissionless so anyone can join? Right now it's permissioned by the coordinator. And also the transaction ordering, what is going to happen? Today, the coordinator decides the transaction ordering. Of course, right now we do it like by ourselves, but we have to look for ways on how to allow people to choose how to do it and how to participate in a network. There are many options about this. There's a lot of studies. Right now, Scroll is looking what is the best way to making this happen. Yeah, but this is very interesting. If you like all these architecture things, I think you should dive into the Scroll docs. And also there is a lot of literature about this, a lot of ideas. I invite you to participate, like all these possibilities. But of course, if you are a developer, what you need to know is that this structure help you so your app is cheaper and faster and secure by Ethereum. Okay, thanks for watching, and see you in the next video where we're going to talk about just deploying a smart contract on Scroll. See you there.